Hello, welcome to Amazing Age Academy. In today's lecture, we'll be looking at indices. So we'll be looking at the numerical form of it. Supposing we have a multiplication of this form, let's say 3 times 3 times 3 times 3. So the problem is this is already in a compact form. So we'll try to reduce this compact or more or less a repeated multiplication to a simplified version. So as we see we have 3 multiplying itself again, multiplying itself again, multiplying itself again. So first of all, write 3. Now because we have how many 3's? This is 1. We have up to 3. This is 1. Okay. This is 2. This is 3. And this is 4. So we can simply write this in a simplified version and say 3 raised to power 4. So writing it in this form is nothing else but what we will now refer as an index form. So we have written this in an index form. Okay. Now, this power, we have power 4. This is an index. So if we have it more than 1, we can call it indices. So we can evaluate this if we want, knowing that here will give us 9. Okay, 3 times 3 is 9. And here, 3 times 3 will give us 9. So when we multiply this gives us 9 times 9. And we can leave it as 81. Okay. But what is important to us is the index form which we have above. We can look at another example. Supposing we have something like 2 times 2 times 2 times 2 times 2. Again, we can see that 2 is repeatedly multiplying itself. So we first of all write 2. Okay, we go back to count. Supposing we have 1, 2, 3, 4, 5. This means we have 5 2. So this will be 2 raised to power 5. Okay, and we can evaluate this and know what it is. For instance, if you want, we know that here maybe will give us 4. We know that here will give us 4, and we have 2 here. So this is 4 times 4, 16 times 2. So this will give us 32. Supposing if we're interested in getting the final value, supposing we have another example, say we have 4 times 4. Okay, this can be written as usual as 4 raised to power 2. But in this case, we can call this, because we have 2 here, we can call this squaring. Okay, so this is the same thing as 4 squared. We can have another example. Supposing we have 5, okay, times 5 times 5. Okay, so as usual, we have 5. So we first of all write 5, and we know how many values of 5 we have. This is 1, this is 2, this is 3, and this is 5 raised to power 3. And we call this 3 cubing. So this can be written as 5 cubed. Okay, we might look at another example. Supposing we have something like this. Okay, we have something, let's say we have 3, okay, times 3, okay, times 2, okay, times 2, okay, times 2. So we look at this and say to ourselves, we have 2 numerical values here. So we have 3 here, okay, and we have 2's here. So because of this, we simply write this as 3 times 2. So we write this first. After we have done that, we go back to count. How many 3's do we have? We have, this is 1 and this is 2. So we write 3 raised to power 2. We go back to count for the 2's. This is 1, this is 2, this is 3, and write this as 2 raised to power 3. So this is our index form of this compact or repeated multiplication. We look at another one. Let's try to look at an algebraic form of this. And remember what we mean by algebraic form when we involve letters. Okay, we'll see now. So algebraic form, we look at an example. Supposing we have something like this. Let's say A times A, okay, times A times A times A times A. Again, this is a repeated multiplication. So we first of all write A because that's what we are seeing repeatedly. So okay, we count and say, okay, we have 1, we have 2, we have 3, we have 4, we have 5, we have 6. So this is A raised to power 6. Okay. We can look at another example. Supposing we have something like this. Supposing we have 5, okay? So let's use white color. Supposing we have 5, okay, times A, okay, times A, okay, times A. So this will give us, we simply write 5. So we write this 5, okay, multiplied by A, because we have A's here and 5. So we go back to count. So we can see this is 1, 2, and 3. This will give us 5 times A raised to power 3. So this is an algebraic form because we have letters there, letters like A. So we might look at a general form of this. Supposing we look at the general form, let's see how it will look like. We try to generalize what we have said and call a general form. Okay, supposing we have something of this nature. Okay, so we have, let's say, y raised to power n. Y raised to power n. N is the power or the index. So this will give us a repeated multiplication of y by itself. So we have y, okay, times y, times y, okay, times, the dot means the multiplication continues up to n, so times y, okay. Recall that this n can be any value. Like for instance, our n can be 1, it can be 2, it can be 3, and so on. Fine, that's what we have. So we'll refer this now, okay, we refer this as something like repeated. We say repeated n times. So we are repeating the multiplication, repeated n times. Okay, repeated n times. So that's what we have. So we might finally look at the like something, let's look at something like base. Let's talk about base now. Okay, let's talk about base, let's talk about index, okay, and let's talk about something we call coefficient. Okay, we look at this coefficient, right? Supposing we write it in a general form. Supposing we have a constant, we have this is a constant. A constant can be any value like 1, 2, or 3. We have something like y, a variable, and we have our index or power called n. Okay, now what do we call this power? This power, this is what we call, okay, we call this power or index. So this is index, okay, we call it index or power or power. When there are more than one, we call it powers or indices. So this one, the variable, will refer as our base, okay? And this constant value is constant value, okay? This constant value will refer as our coefficient. And observe that this is involved when we are dealing with variables. So we can look at some examples in what we have done so far. Let's go back to the algebraic form. If you look here, you observe that this 5 will refer this 5 as our coefficient. Okay, so this is what? Our coefficient. Good. And what do we call this man here? This power is what we refer as our index or power. Call it index or power. And of course, and our A, this letter A or the variable A is what we refer as our base. Okay, in this and in other examples we can see. So we conclude this lecture with a summary and see in general what we are saying. So we have said in numerical form, when we see a compact multiplication, this is compact, we can write it in a simplified form. So this simplified version is what we call the index form. And when this power, if this power is more than once, supposing we have 3 raised to power 4 times 3 raised to power 2. So you look at this power and look at this power. So we talk about indices or powers. Okay, indices is a plural of an index. So the algebraic form, we have this value a multiplying itself repeatedly 6 times. So this could be written as a raised to power 6. So in general form, we can take any variable of this form, supposing we call it y, and this power we raise this to power, maybe we call it n, and n we said could be any value like 1, it could be 2, it could be 3, and so on. So we call this a repeated. This is repeated n times multiplication. So we talked about the notion of base, index, and coefficient. So we can see a value like this. So y, as you can see, y is the base, okay? Base because it is carrying something. So this y is carrying a load, which will now refer as an index or power. And this is a constant value, okay, which will now refer as a coefficient. So in the next class, we'll be looking at the laws of indices. Have a nice day.